Hello everyone. So let us continue with the next type of problem. Okay, so analyze the continuous beam by displacement method. So again, displacement method, it's also known as stiffness, that is stiffness matrix method. All right. So this is the given problem wherein there is AB is overhang, then BC and CD are simply support. Then it is having a point load throughout. So it is 40, 60 and 80. Now you can see here AB is the overhang. So whenever there is a overhang, you have to convert that beam into a equivalent beam. Okay. Convert the overhang into a equivalent beam. So next step is, so it is like this. Now you can see here 40 into 2. It is going in anti-clockwise direction. So show a anti-clockwise movement. Then BC and CD. Okay. Then as usual, mark the I values here. It's 2I, 1.5I. Okay. All right. So after this, the next step is, okay, however, I have not found out the kinematic indeterminacy here. I have directly used here, but you need to calculate the kinematic indeterminacy. That is, only after this equivalent, drawing the equivalent beam, you have to mark the coordinate directions 1, 2, and 3. So before you could mark this, so use the formula Ki is equal to 3J minus R plus M. So 3J, joint is 1, 2, and 3. So 3 into J, that is 3 into 3, 9, minus R, reaction. Reaction is 1, 2, 3, and 4. Reaction is 4. R plus M. M is 2. So reaction is 4. Members are 2. That is 4 plus 2 is 6. And this is 9. So 9 minus 6 is 3. So we have to show here the rotations. Okay, that is, the meaning of this is, here in hinge it cannot move in horizontal or vertical, so it can move only in the third direction. That would be a rotation. Likewise here also, hinge support, it cannot move vertically because there's already reaction opposing it, so it can move only in the third direction. The third direction happens to be the rotation. Likewise here also, in roller support, it cannot move vertical, but it can only rotate. Okay, it can. So now the Ki value is 1, 2, and 3. So it is in 3 different directions. Okay, then as usual, find out the fixed end moments. Okay, so before we could start that, find P. So P is nothing but the rotations or the movement acting at that particular joint. So the first joint happens to be a B, C, and D. So at B there is already a moment. So it is 80. We have converted this overhang into a moment. Okay. So 40 into 2. So this is 40 into 2, but now it is going anti-clockwise. That's why it's minus 80. So all the clockwise rotations are positive, anti-clockwise rotations are negative. All right, in that case, so it is minus 80. Then at C there is no moment, so it is 0, and at D also there is no moment. So it is minus 80, 0, and 0. Okay, so this is P. Next is, once you find out this P, next is find out fixed end moments. So in fixed end moments, it is MFBC. First find out MFBC. Okay, so it is WL by minus WL by 8. No, just a moment. Okay, so it is acting exactly at the center. Okay, so it is acting exactly at the center. All right, so it is minus WL by 8, and second one is plus WL by 8. Next, MFCD. MFCD is minus WL AB. This is A. This is eccentric. Okay, so A is 4. AB square by L square. MFDC is W A square B by L square. Okay, likewise find out this. Next, I've shown another diagram wherein whatever you found, okay, you have marked it here. We have marked it here. This is minus 60 anti-clockwise. MFCB is 60. C to B. So it is again positive clockwise. Then again CD is minus. So it's minus MFCD, and MFDC is plus. Okay. All right. Once you mark this, next is find out PL. So PL is nothing but because of the load. Okay. So because of the load, the first joint is B here. So from B, this is the first joint. Okay. So it is MFBC. This is the first member. Next is, okay, you can see here, this is A, B, and C. MFBC is the first member. Then second is MF CB plus MF CD is the second. Next, at D, it is MF DC. Okay, same thing we have written here. First, MF BC, that is minus 60. Next, MFCB plus MFCD, this joint, MFCB plus MFCD is the second joint. Okay, we've added this. And next is MFDC. MFDC, it's 71.11. Okay, and then add this, calculate. Okay, then we'll get PL. Okay, then we can use this value P minus PL later in the last equation. Okay, now the most important thing is finding the stiffness matrix. Okay, now to find the stiffness matrix, again the same thing. First we'll apply a unit rotation at 1, then find out how much is K1 1, K2 1, K3 1. Similarly, we'll find out the unit rotation at 2, that is theta is equal to 1 at 2. Then we'll calculate how is the deflection left and right. Okay, and then similarly find out the K values for this. And finally, we'll apply unit rotation, that is theta is equal to 1 in the third direction, and simultaneously find the K values. Okay, so in this problem, we'll get three displacements, that is three unknown factors. All right, that is at A, B, C, and D. All right, okay. Next is the first step, that is we'll find the unit displacement at B. Okay, so first we'll apply, that is the one unit rotation, that is theta is equal to 1 radian at B. So unit displacement at B, theta is equal to 1. Okay, now if I apply, again, always the rotations are clockwise. So here, if I apply a unit rotation clockwise, that means it tries the BC. The BC beam will bend downward like this. Only in span BC there is a rotation. Okay, so the red line indicates that beam is deflected, bent. Okay, once you draw this, next mark this K11, K21, and K31. Now here, see here, how to write this is very important. K1, first write K1 because the first direction. K1, second direction, K2, then K3. Okay, first write the first number here, 1, 2, and 3. Next, you have applied a unit rotation at 1. So whatever effect you get here in this diagram is only because of 1. So that's how you should write next number, that is 1, 1, and 1. Okay, the first number signifies the direction of that particular stiffness matrix, that is K1, K2, K3. Okay, then you write, you have applied a unit rotation at B, unit rotation at B, that is at the coordinate direction 1, so it is 1, 1, and 1. Okay, all right. Next thing is finding out the factors, that is K11. So K11, it is bent here, so only from this beam, so it will be MBC. Okay, so MBC is equal to this one, you have to write this, so it is 2EI by L. So 2EI by L, I is 2I, so it is 2E by into 2I divided by L, that is 8, plus again B, it is the starting point. Okay, you're measuring from this point and you're applying the load at this point, so it is 2 times theta B plus theta C. Okay, so again one more thing, wherever you're applying the load, that particular joint should be released. So of course I've not shown here, but you have to release this joint. Only if you release the joint, then you get the theta here. All right, so theta B exists, and here theta C is fixed, so it is 0. Okay, then solve this, you'll get K11 is EI. Okay, then next, similarly find out K2. So now K2, just check the deformed shape of the beam. So deformed shape of the beam here is K21, that is 2EI, again same 2E into 2I divided by L. Again, from here you're measuring, so this is the first joint, so it is theta C only. First, if you measure like this, that is, if you write it in a sequence, 2 time this is theta B, plus you're applying the moment here. All right, this moment you're checking, so it is the first, you're measuring like this, CB, so it is the joint from where you're measuring, so it is 2 times theta C. Okay, so again as usual theta C is 0, so K21 is 0.5 EI. Then K31, in K31, see here again there is nothing getting deformed, There's no red mark here. I've marked here. There's nothing getting deformed, so that would be 0. Similarly, calculate unit displacement at C. Okay, now see, release the joint, release the support at C now. So it is B and C, you have to fix it. Then apply unit displacement at C. That is theta C is equal to 1. So theta C is equal to 1 radian. Okay, so when you apply a moment like this, that is, here there is a rotation here, apply a rotation here. So when you apply a moment here, CD bends. Okay, CD bends downward. Okay, again the same moment, if it is acting in BC span, it will push the beam upward. All right, so now B, C, and D. So this would be uh, after you draw this deflected shape of the beam, then mark K. Okay, K. Okay, now see here. First, again, when you mark this B, C, and D, mark K. That is, K is equal to K1, K2, K3. Write down the first number K1, K2, K3, because those are three different coordinate direction. Next, now you're applying the rotation in second direction. Okay, that is a C. That means second coordinate direction. So the next suffix number, the next number would be 2, 2, and 2. All right. Okay. All right. So once you mark this, next is again finding out K1, 2. That is only MBC. So MBC you mark. So MBC is equal to 2EI by L into, again it's a from B you measure, so it's 2 times 2B plus theta C. Okay, and here again 2B is 0 because it's fixed. Only when you, wherever you apply the load, that is rotation, at that point you should uh, release the fixed support. Okay, then solve this, then you find K12, then K22, that is this thing, K22. Now K22, it is affecting both side of the beam, that is CB and CD also. So it is MCB, MCD. Okay, so MCB and MCD. So MCB is nothing but you take this left side 2EI by L into, one second, that is left side and right side. So it is 2EI into left side 2I divided by L. Then you're measuring from C is the first joint, so it is 2 times theta C. Okay, plus 2EI by L, again here it was 1.5 times I, then to the right side of C. So only C will exist, so it is 2 times theta C. Again, no need to write theta D and theta B because they are already termed 0. Okay, then solve this, then you'll get K22, that is 2EI. Similarly, K32. So here K32, only this span is affected, only you have to measure this. So DC. So DC is K32, that is MDC is equal to 2EI by L. 2EI, I is 1.5I divided by L is 6. Again, um, 2 times theta D. This is plus theta C. So D is 0 here. Okay. So once you mark this, then find out. So it is K32 is 0.5 EI. Okay. Next, at D. Next, apply unit displacement at C. That means fix all other two supports, release joint D. When you release joint D, so theta D is equal to 1. So theta D is equal to 1 now. So only CD is getting deformed. The other two supports are fixed. Okay. So mark this B, C, and D. Then mark this now. Rotation. See here. Actually, it is K13. Okay. It is K. See here, as usual, write this K1, K2, K3. Understanding this is very important, otherwise very confusing. So first alphabet, first number, whatever you write is the coordinate direction. So it is K1, K1, K2, K3. Okay. Next, you're applying a rotation at D, that is in third coordinate direction. So that's why it is 3, 3, and 3. Okay. All right. So once you mark this, next is find out. See here, you're applying a unit displacement at D. So it is K13. So K13, nothing is affected. This beam is not getting deflected only or deformed. So this term would be 0. Next, K23. So in K23, just check what is getting deformed. CD is getting deformed. Okay. So CD is nothing but 2EI, only this portion, 2EI by L. So 2 times theta C plus theta D. So theta C is 0. Only D should be released here. Okay. So it's 0.5 EI. Next, K33 is equal to same thing. Again, 2EI by L, 2 times, again, first theta C, far end, near end is always multiplied with 2. It is 2 times theta D. So theta C is 0. So it is only 0.5. Okay. So it's add this. So it is 0.5. So this, when you add this, it is EI. Okay. So next step is, all right, next step is find out, write down the stiffness metric equation. So the stiffness metric equation is given by K into delta is equal to P minus PL. K into delta is equal to P minus PL. So K is nothing but, again, write this formula thoroughly. So K is K11, K11, K21, K31. So first it is like you have to write the rows. This first number indicate row, second number column. So K11, K21, second row, first column, third row, first column. Similarly, K, again, first row, second column. This is the second column. And this is the third column. Okay. Next, delta 1, delta 2, delta 3. This is nothing but the unknowns which we need to find. Next, we've already calculated P minus PL. So P is minus 80 plus 60. Then this is PL. All right. That is in B, C and D directions. Okay, then solve this. So put in, again in this equations, put this, that is EI, put the values K11, K21, be very careful. So again, when you're putting this, first would be, see here, K11, K21, K31, K11, K21, K31. So first would be the column which will be filling. Then fill all this column one by one. Next, simplify this. Next, take common here and then keep this 1.50, 0.52, 0.5, 0.51, delta 1, delta 2, delta 3, the three unknowns. And this is the P minus PL values. Next, ultimately we want is delta 1, delta 2 and delta 3. Now to find out this, it is like we have to take this EI goes here, EI goes here, and this matrix here. If you want to keep this, you want to find out this value. So 1 over EI into this comes to this side, that becomes inverse, and this remains same. So this is inverse matrix. Again, I have done manually here, but again, it's always better to do in the calci. It's not that if you do manually, you'll get full marks. If you do it in calci also, you get full marks. So it's always better to do it in calci, wherein you'll not end up in making any mistakes. So again, I've told you how to do it in the calci. Now this time, there are three unknowns. So you have to consider the matrix wherein you have three unknown factors. That is, you need to calculate theta B, theta C and theta D. So again, how to do it, I'll tell you. So first, what you need to do is, I've been using FX991 MS Calci. Okay, so first press mode 1, 2 and 3 times. So when you press the mode button 3 times, so you have equation, mat and VCT. So choose the second option, that happens to be mat. So now it is in the matrix mode. The Calci is in matrix mode. Now what you are supposed to do is, again, shift 4. So shift 4 in the Calci means shift mat. Okay, in the Calci. So press shift and the number 4. So you'll get dim, that is dimension edit matrix. So choose the first option, that is dimensions, DIM. So after you press DIM, then you have A, B and C. So A is the first matrix A. So we'll choose A here. So that is 1. I'll press 1. Then it will ask for how many rows and how many columns. So here 1, 2, 3. Okay, 3 rows and 3 columns. So I'll press M. So I'll type M, mat A. M is 3. N is also 3. Okay, then it will ask for the numbers. So mat A11, that is 1.5 and 0. So accordingly, it'll start from this 1, 2 and 3. Okay, so then 0.5, 2, 0.5, then 0, 0.5 and 1. Okay, then so this is fed in the calci, this is over. Now again you can press AC button, so it is already fed in the calci, it is in the memory. Now again shift, again press shift 4. Okay, shift 4. So you'll again end up in dim, edit and matrix. So first choose dim, dim, that's the first matrix. Then second option, now you have already fed A, now choose matrix B. It is like matrix A, this is matrix B. So matrix B, choose matrix B, that is second option. Then again it will ask mat B m into n. So again here it is 1, 2 and 3. So it is 3 rows and n is column is 1 column. Okay, once you choose this, then it will ask mat B 1, 1. So it is minus 20 and 2, 1 is minus 24.45 and 3, 1 is minus 71.11. Okay, so now both the mat A and mat B is fed in the calcium. Okay, now what you have to do is you have to multiply this matrix multiplication. So mat A inverse, mat B. Okay, now again press shift 4. Now this time you have to use the third number, that is third number 3 matrix. So in matrix again to ask A, B, C. So choose A. Okay, so mat A. So again in the calci you can see it is like mat A. When you press this, you'll get mat A. So mat A, again, choose the option inverse. That is in the second line, that is x inverse. You can see that in the calci. So it has x and raised to minus 1 in it. Okay, choose that. Then into, next, again, shift 4, third option, that is mat. Again, second. Then once you press 3, then press 2, that is mat B you're choosing. So it's like mat A inverse into mat B, which is equal to now it is multiplying. So once you multiply directly, see here, solve directly in the calci. So once you multiply, you'll get the values. That is, I've got now the first value, theta B. First value is minus 27.03, then 14 point plus 14.04, and next is minus 78.14. Okay, when you're seeing this, use the right arrow. The first, after the first, finding the first theta B, next use the right side arrow in the calci. If you use the right side arrow, you'll get the next term, and similarly the third one. Okay, so and be careful with the minus sign also, because if one sign goes here and there, if it is plus becomes minus, minus becomes plus, the complete problem, the last answer will go all haywire. That's why you need to write this signs, consider the signs correctly. All right. So once you get this theta B, theta C, and theta D value, next is just the substitution. So again, put all these in the first equations here. Put it back in the equations. That is in this equation. Okay. That is MAB. Okay, so MAB is equal to, okay, these are again the slope deflection equation. MAB will not exist because it's overhang. So MBA is the, MBA is nothing but it is a overhang which is minus 80. Next, MBC. So MBC is equal to, again, fixed end moments plus 2EI by L. So 2 times theta B plus theta C. Okay, find out this. So MBC, you got MBC. And next MCB. So MCB, again same thing, put fixed end moments plus 2EI by L, then theta C plus 2 times theta C plus theta B. Okay, same thing. These are equations, nothing but which we have used previously in the slope deflection equation. The same formula should be applied here. And then finally MDC is equal to 0. Okay, once you solve this, you'll get 0. Okay, so these are the final moments, and once you get the final moments, if you want, you can just draw the bending moment diagram as like we have done before. All right, the only different thing about this problem was it has three different coordinate directions, so you should use it very carefully. Draw the diagram very carefully. All right, that's all for today. Thank you.